All right. Starting with number one, verify the following identities. So we can start off just by seeing that, okay, I have two terms here. I'm trying to get it down to one term. What if I just went through common denominator? Okay, so add those two fractions together. I can think of this as tangent over 1. Okay, so what's our common denominator? Tangent, okay. Need to balance fraction. The first one, denominator does not change, so I can just bring down that 1. Second denominator, there is a change. This 1 is missing a tangent b, so I need to multiply the top by tangent b as well. Tangent times tangent is tangent squared. Right, so now that I have common denominator, I can put it all into one fraction. We have an identity there. 1 plus tangent squared equals secant squared. Yep. And we're at the end. Okay, number 2, 1 minus cosine squared over sine 2x. Looks like I can do some changes, right? 1 minus cosine squared, there's an identity there. Sine 2x, we also have double angle identity that we can use. Minus cosine squared, sine squared. Sine 2x is 2x cosine x. Thank you. Put everything out, separate everything here. We see sine and sine, which just cancel out nicely. I'm left with sine over cosine, right? And really, I can just think of this as this 2 is really a 1 above, right? So it's really 1/2 times sine over cosine. At 2, remember, the nice thing about multiplication is I can move and flip or change things, or allow me to give separation, and that helps me see things a little bit better. Sine over cosine is equal to tangent, so we have our result set. Okay. Cosine 2x. We have 3 options available. You got cosine squared minus sine squared. You got 2 cosine squared minus 1. And you also have 1 minus 2 sine squared. Right, so maybe, well, I think any of these could potentially lead us to the answer here, but we see that tangent can be written as sine over cosine. So it looks like if I can get that sine and cosine involved here as well, then maybe having sine and cosine above and below, we can find a way to eventually combine or to cancel things out. So that tangent, I'm going to play with that tangent first. Write that tangent as 1 minus what? In terms of sine and cosine. Sine squared, right, over cosine squared. Common denominator to kind of get that denominator going. So I can kind of merge fractions together. Still waiting to see how that denominator looks before I make a decision as to what I want to choose for that cosine 2x because I have a couple of options. But here, my common denominator is going to be cosine squared x. Common denominator is cosine squared x. This one is missing a cosine squared, so I need to multiply the top by cosine squared. So you see how this is going to end up being cosine squared minus sine squared. And so now I think I'm going to make an educated guess that cosine squared minus sine squared could be a good fit, right? Especially if I see it in the denominator there. So I'm going to replace cosine squared with cosine squared minus sine squared. Now, if you happen to make an incorrect, or if you choose another one, you can still get to the right answer. It just will take a little bit longer. Okay, so it's just, you know, if you can identify one that's a better fit, then it'll speed up the process to help you get to matching everything up. Okay, any questions so far? So that denominator I'm going to kind of push together down to one fraction. So now I have a complex fraction, but it's a numerator divided by a denominator. But I can move this up by dividing, the same thing as multiplying by the denominator's reciprocal. So I can flip that up to the top. Okay, cosine squared minus sine squared. Left with cosine squared. Okay, number 4. Secant y plus tangent y. I think the hint is looking at the right side. Everything's in terms of sine and cosine, so I'm just going to go ahead and make that adjustment there. So secant is 1 over cosine. It's already showing me common denominator, so okay, so it's not quite looking the same as where I want to be, but we know that we can make something out of nothing by multiplying numerator and denominator with an expression that will allow for identities to occur. So I think we can either multiply the top and bottom by cosine y, or multiply the top and bottom by what? What's the other option? Yeah, 1 minus sine y, right? So either one will get you to where you want to be, but it's just nice to be comfortable with both, right? It just kind of gives you more tools, and you know, the more tools you have, the faster you'll work, and the more efficient you'll be. But I'm going to choose the 1 minus sine y, just for practice purposes. But you could multiply top bottom by cosine y, and you're going to get the same result. Okay. I'm going to FOIL this out here. So this is 1 minus sine y plus sine y minus sine squared y. The middle terms will drop out. You'll just only be left with 2 terms here. And the denominator, I'm going to leave it separated, right? Because that 1 minus sine y is already showing for me. I don't want to lose that. If I distribute the cosine through, I kind of lose that parentheses. That's already a match for my end. Okay. That 1 minus sine squared y, we should be able to recognize this as difference of squares, right? A squared minus b squared, I can factor. A squared minus b squared is a minus b times a plus b, so okay, nice fit. The denominator. let's see. Oh, sorry. I don't want to do this, right? Because, sorry, I'm back to where I started. My bad. I want to find a way to get the cosine to go away or to flip-flop. So let's change this 1 minus sine squared to be what? Be cosine squared. Okay, that's a better fit. Cosine squared, I can take one of the cosines out. So I'm still left with one cosine above, and there we have it. That's where we want to be. I'm going to start on the right side here. Again, on the test, you always get to choose which side to begin. Let's just start on the right side here. This looks like it's easier to get it cleaned up with something more to work with. So, oh, sorry, I wasn't sorry. I'm going to start on the right side here. I know I can quickly get this in terms of sine and cosine, and then hopefully things will combine, and I can eventually, hopefully, make it look like one of my identities. If I can make it match one of my cosine identities, then I know that I'm good. I can make my final statement. So first thing I'm going to just try to rewrite tangent is cosine, sine over cosine. It's like I can go through a series of common denominators, right? Numerator up top and below. Cosine squared x is my common denominator. Looks like there's some balancing here, so multiply the top by cosine squared x. The second fraction is matching, so just keep that sine squared. The denominator here, also cosine squared. Common denominator. Balancing fractions here. One's missing that cosine squared, so I multiply the top by cosine squared. Okay, let's put all this together here. Okay. At least I have it down to a fraction divided by a fraction. I can multiply by this denominator's reciprocal. Okay, we see the cosine squared goes away nicely here. All right, looks like we have a lot of stuff here, but we can actually do something here, right? What's cosine squared plus sine squared? You have an identity there, equal to 1, right? So just make all that 1. So essentially it goes away. And the only thing left is cosine squared minus sine squared. And cosine squared minus sine squared is an identity for cosine 2x, so we can make that final jump. Squared minus sine squared is equal to cosine 2 theta, or 2x.
Mr. Yang, what if we
Yes.
converted the like I also started on the right side,
Uh-huh.
but I converted the 1 plus tan squared into the secant
Oh,
squared.
secant squared. Yeah, you're right. That may be faster. Okay, that's good.
But you could still do that, right?
Yeah, that works. Yeah, they can split
Okay.
up into fractions. Yeah, make that sine over cosine and 1 over cosine. You flip it, and you end up with cosine squared minus sine squared. Yeah, that works. I didn't see that. Yeah, you're gonna have multiple ways to get to your answer. As long as every step follows logically from the previous step, you know you're good.
All right.
All right, number 6. Looks like if I can expand everything out, hopefully that will turn into something that I can use to make it look like that right side. So sine of 2x, there's only one option there to expand. And cotangent x, I can convert into in terms of sine and cosine as cosine sine. It's like I can quickly get my sine x to go away, numerator, denominator. Only left with 2 cosine squared x. But I want this in terms of sine, so let's think of our identities here. We can get cosine in terms of sine. If I rearrange cosine squared plus sine squared equals 1. If I rearrange this and if I solve for cosine squared will be equal to 1 minus sine squared, right? And then just distribute that 2 through and we should be able to make our match. Okay, 7, I'm going to start on the right side again. Looks like it's usually easier to simplify something rather than trying to build something out of nothing. So I'm going to work with that cosecant 2x and cotangent 2x. Now, neither of these are double angle identities, but we can get it in terms of something that feels more familiar, right? So cosecant is 1 over sine. And I have something for some sine of 2x, so I know I can work with that. And cotangent is 1 over tangent. We have an identity for that, we can work with that. Oh, actually, better yet, let's do cosine over sine. That's even better. Tangent is a little messy, and it's better to match with what we have on the left side there. Yeah, so let's do cosine over sine. Common denominator is already showing, so I can just put it all together. Sine of 2x, I only have one option. I'm trying to work towards tangent, right? And tangent is sine over cosine. So again, any one that you choose for cosine, it'll eventually get to your answer. But I'm going to choose in terms of sine because I think that will help me get closer to where I want to get faster. Because eventually I want sine above and cosine below. I'm hoping that one thing will cancel out. So for cosine 2x, I'll choose the option with the sine in it. The 1 minus 2 sine squared x. And the sine of 2x, there's only one option. Okay, distribute the negative through. One minus one cancels out. 2 sine squared x, same thing as 2 sine x times sine x. You don't have to do this. I just want to just show that a lot of this will cancel out. Twos goes away, sine goes away. I'm only left with sine over cosine, and sine over cosine is
Mr. Yang, can you go back over like where you pulled out the -1 from the 1 minus cosine 2 x?
let's see. This first step here.
No, it's like
from the previous number 6.
no, it's on number 7. It's like on the second row,
Okay.
the first thing, like how you got that.
Oh, okay. So cosine of 2x, I'm making a substitution here. Cosine of 2x is equal to 1 minus 2 sine squared x. Because that's one of my options, right? I can, whenever I see cosine 2x, I always have 3 options to choose from. These are all the same.
Okay, I see that. Okay, yeah, my fault. Yeah, I see that.
Good. All right, so I'm choosing sine just kind of as an educated guess because, I want sine above and cosine below, and hopefully that will help speed up that process to get there. All right, number 8. Let's see what we can do to clean up to begin with. I see something that's easy to just substitute. Sine squared and cosine squared becomes 1. So either we can get everything in terms of sine and cosine, or we can just convert the tangent in terms of cotangent. If everything's in terms of cotangent, we're hoping that will just kind of move us towards the goal here. So what if we just play with that denominator there, get that denominator to show cotangent. Okay, common denominator. Leaving the numerator alone. The numerator is already showing me 1 plus cotangent squared. It's pretty close to where I want to be. Oops. Okay, so my common denominator is cotangent squared. Hey, morning. So I want to balance the fractions here. The 1 is missing the cotangent square, so I need to multiply the top by cotangent square. Second fraction is already showing cotangent square, so I just bring that 1 down. Okay, so numerator divided by denominator, same thing as numerator times the reciprocal of the denominator. Looks like I have a nice match between my numerator and denominator, so that can go away. Only left with cotangent squared. Okay, any questions so far?
I think there's full sheet, so.
But if you choose to do without the sheet, that's your bonus. It'll be like plus 5 points or something. Okay, number 9. Okay, I'm gonna start with the left side here. There's more things to work with. Okay, so I'm gonna get everything in terms of sine and cosine. Looks like I can find better matches if I can just get that tangent to turn. Looks like I need to get a common denominator going. Merge the two fractions, since I only want one term on the right side. Okay. First denominator is missing a cosine, so I need to multiply the top by cosine. Second fraction is already the same denominator, so just keep that sine squared. Merge the two fractions together. There's an identity that's nice to work. That it's nice to see. Cosine squared plus sine squared is 1. 1 over cosine x equals secant. Hey, number 10. Looks like if I just get everything as common denominator, I should be able to make some progress there. So my common denominator here is a little bit more than just one or the other. These are completely separate denominators, so I need both of them to create my common denominator. Okay, so we compare between our old and new denominator. Looks like the old denominator is missing the 1 plus sine theta, so that's what I need to balance out with the top. So 1 plus sine times 1 plus sine. To FOIL that out. Okay. this one, there's 1 plus sine theta, old denominator is missing the cosine theta. So I need to multiply the top by cosine theta. Now that I have a common denominator, I can put all of those terms in the numerator all together. Okay. Sine squared plus cosine squared becomes 1. 1 plus 1 is 2. Getting closer, but there's still something we can do with the numerator. We don't want to try to cancel anything out, right? That is still too early. That plus is getting in the way between the numerator and denominator. So what can we still do in the numerator? We can still factor, right? What can we factor out? 2. So if I see that 2 is shared between these two terms here. So if I take out a 2, that means I'm dividing by 2, right? So whenever you take a GCF out, you're always dividing your original expression by that GCF, and whatever is left over goes inside the parentheses. So 2 divided by the GCF, 2 is 1. 2 sine theta divided by the GCF 2, it's just 2 and 2 reduces to be just 1, so I'm just left with 1 plus sine theta. Now we can reduce 1 plus sine theta, can go away. I'm left with 2 over cosine theta. 2 over cosine theta, you can flip that cosine up to the numerator as secant. So we have our end result.
The 2 over cosine theta is
Yes, and the reason why is because of this. I can break it down a little more. So 2 over cosine. You can think of cosine as 1 over secant. If you write it this way, you can think of it as,
okay.
multiplied by the reciprocal. All right, let me find some more sum and difference identities that we can practice with. I didn't put it on the sheet here.
So, Mr. Yang, when you're creating something out of nothing,
Yeah.
it doesn't matter which one you use, right?
Yeah, it typically doesn't matter because whatever you do, you'll be able to somehow find a way back to where you want to be. The whole thing with creating something out of nothing is just to get an identity introduced into the problem so that you can have something to work with. So yeah, it doesn't
All right.
really matter.
So you'll get
Sometimes
both. So you'll get the
sometimes
same
one way
answer for
may
both.
get to the answer a little faster, but it really doesn't. It doesn't really matter.
Okay.
Yeah. Okay. On this packet here, worksheet 3. Let me change this first problem here. I just want to do an identity, sum and difference identity that we can try here. equals 2 sine A cosine B. Okay, look on your formula sheet here. Sine of A plus B. These are the way that the formula is given. It's always combining two formulas together. So if I'm using my top operation, I got to match with the top operation. So looks like in this case, it's going to be plus a plus. So sine of A plus B is just sine A cosine B plus cosine A sine B. Okay, so sine is pretty straightforward. When you get to cosine, though, just be careful because cosine of A plus B equals cosine A cosine B minus sine A sine B, right? So you want to match top operation with top operation. If you want to use the bottom operation, you got to use the bottom operation. Okay, what do you guys see here? Any like terms, anything that we can combine or remove?
You can remove the cosine A, sine B, and
Yep.
yeah, on the very
These are
right.
the exact same, just different signs, so that goes away. These are also the same, but they're the same signs, so if we add it together, we get two of them, right?
Is
Okay,
the
how about this?
formula
Oh,
sheet that
sorry.
we're gonna get gonna look the same as like the one we have right now?
What do you mean?
Like, is it gonna be like the exact same one, or is it like is there gonna be like some that we don't like need? Because like, which one was the one that we're not gonna get?
Oh, yeah.
Uh,
So we're not gonna use these here.
Okay, but
Yeah,
just
is that what you're
having.
asking?
Yeah.
Yeah. It'll be
Okay.
on the formula sheet, but you're not gonna touch it. All right, let's try another one with some difference. Let's try this one here. Okay. We can expand that sine x minus y here. So for A, I'll put x. For B, I'll put y. Okay, look at the structure here and look at what we're trying to get to. What would your next step be that can move us closer towards that right side?
I did was I just like put sine x cos y, x cos y.
Oh, sorry,
I
my bad.
I split the bottom.
Good, yeah, so that's not a minus side there, I messed up. It's cosine x cosine y. So you say you split into two fractions?
I
Good.
split it,
Yeah.
and I crossed out the cos y in the first
Hmm.
cos x, and it gave me sine x over cos x, which gives you tan x. as sine y over cos y, which gives tan y.
Good. I think you know, part of the thing that we gotta be careful, or that we have to be able to do, is we need to kind of be able to get to that point, right? Like, how do I know when to split a fraction, when I know when to combine a fraction? So the hint is that, oh, this is messy, but this is one fraction, right? But I'm trying to end up with two terms. So anytime you see one fraction and you're trying to get that into two terms, there's the hints, right? Split into individual fractions, and that should help you move closer, right? So this is really in the form of a minus b over c. If I have a minus, as messy as it looks, it's just basically this, a minus b over c. I can split this up into a over c minus b over c. That's what I'm going to do. Okay? So even though you may not see the end, you know that you're kind of moving in the right direction because you're able to split into two fractions. Okay, so now we can see, as the dust settles, we can see what we can remove and cancel and combine. So the cosine y's. Now these are two fractions. These are independent of each other. So I can kind of just handle everything within this fraction and then handle everything within this fraction. Then we can combine at the end. So we don't have to worry about, you know, having to worry about the other fraction when you're trying to cancel things out. So you see cosine y matches, so that completely goes away. And we're left with sine x over cosine x, and that nicely turns into tangent x. And here, second fraction, cosine x goes away. But we're left with sine y over cosine y, and that turns nicely into tangent y. We have a minus in between. That matches what I'm trying to reach.
The first, it's first four questions about tests, like the ones without the verified.
I think it is kind of like verifying. It's just you're simplifying down to the point where it'll eventually match one of your choices. So you're still reducing it. You just don't have as much of a clear goal, but yeah, let's see. Hey. Oh yeah. Okay, so here's one where you're just asked to simplify. you don't have an end goal in mind. You're just trying to clean up as much as you can and see what you get, because whatever you get, if it's simplified enough answer, it should show up in your answer bank, and then you can choose that answer. So here, my first step is, okay, maybe everything in terms of sine and cosine, that will help me move closer to my goal. I got two complex fractions, but I can flip all the denominators up as reciprocals. Also flip this denominator up as a reciprocal. Okay, cosine squared times cosine squared, cosine squared theta, sine squared theta. So this should be equal to what? What's our identity for cosine squared plus sine squared? So if this was the problem, then one should show up in the answer bank and you just choose one. Let me do one that involves like a trinomial factoring, where you have to get okay, let's try this one here. Okay, so we're going to ask to be asked to reduce that as much as we can. So we see that we can do something with that numerator there. That's a factoring, trinomial factoring, but we can do an easier version of that problem by doing this one here. 2x squared plus x minus 1. This feels easier, something more familiar. If you want to go through star method or grouping method, either is fine, but either way, we got to go through this little puzzle here. Multiplies to be a times c, which is -2, and adds it to be 1. So what two numbers? Multiplies to be -2 and adds up to be 1. 2 and -1, right? 2 times -1 is -2, 2 minus 1 is 1. We know we're good. If you want to do grouping method, you're going to be playing with that middle term there. Get two like terms to add up to be that middle term. So 2x squared plus, the order doesn't matter, 2x minus 1x. All right, 2x minus 1x is 1x, but we're able to split up and in a form that will help us with our factoring. Look for GCF. Your first two terms, you can take out the 2x. If I divide a 2x from my first term, I'm left with x. If I divide a 2x from the 2x, I'm just left with +1. Second GCF is just -1. By -1 by the -1, I get just x. By -1 by -1, I get +1. My parentheses should match. That's my GCF of my common factor. Take out the common factor. And the the terms without parentheses will get their own parentheses. And now we can get this into our original variable, right? So this is the factored form in terms of x. We'll do the factor form in terms of sine. So replace x with sine. So sine x +1 to sine x. Okay, we see a perfect match between numerator and denominator, reduce, and that's as far as we can get, 2 sine x minus 1.
When it went from 2x, get that, how did it get to the next step out of the 2x?
Right, so this is what we did here. You see how these are two terms here? Right? What's the GCF between these two terms? X +1, right? So imagine taking x +1 out from both those terms. So I'm dividing an x +1 out. If I divide an x +1 out from this first term, what's left? 2x. If I were to divide an x +1 out from this x +1, I'm just left with a -1. So it's like a GCF, and then the leftover gets its own parentheses. Final thing is watch out for difference of squares, right? If I see sine to the 4th x minus cosine to the 4th x. Okay, see, these are both perfect squares, right? You can break them down into their perfect square roots. All right, so watch out for that, right? If I have two perfect squares and with a minus sign in between, I can break them down into a squared minus b squared, or a minus b, a plus b, depending on how you want to break that down. Okay. All right, see you guys, class.